We are exploring why Pluto sometimes overtakes Neptune in distance from the Sun. Traditionally, Neptune is known as the eighth planet, while Pluto was the ninth. However, Pluto's orbit is unique. As shown in the diagram, you can see that Pluto's orbit, in gray, overlaps Neptune's, in blue, allowing Pluto to occasionally come closer to the Sun. This intriguing aspect of celestial mechanics will be our focus in the upcoming discussion. Continuing our exploration, let's delve into the concept of orbital eccentricity. Planets move around the Sun in elliptical paths rather than perfect circles, a principle discovered by Johannes Kepler. Eccentricity is a measure of how elongated these elliptical orbits are. As depicted in the illustration, you'll see a circle on the left representing an orbit with zero eccentricity, indicating a perfect circle. On the right, there's an ellipse showing an orbit with eccentricity greater than zero. Most planets, like Earth and Neptune, have low eccentricity, meaning their orbits are nearly circular. In contrast, Pluto's orbit stands out with a significantly higher eccentricity, which contributes to its occasional overtaking of Neptune in proximity to the Sun. Pluto's orbit is significantly more elliptical than Neptune's, as illustrated here. The eccentricity of Pluto's orbit is about 0.25, compared to Neptune's almost circular orbit with an eccentricity of 0.01. This higher eccentricity means Pluto's distance from the Sun varies greatly. Look at the points marked as perihelion, where Pluto is closest to the Sun, and aphelion, where it's farthest. This variation allows Pluto to sometimes come inside Neptune's orbit, explaining why it occasionally overtakes Neptune in terms of proximity to the Sun. Neptune's orbit, depicted in this diagram, distinguishes itself with its near-circular shape, indicated by its low eccentricity. This means that Neptune maintains a relatively constant distance from the Sun, approximately 120 units as shown here. Unlike Pluto, which has a varied distance due to its elliptical orbit, Neptune's consistent path contributes to its stable position in the solar system. This stability contrasts sharply with Pluto's more erratic path, reinforcing why Neptune is generally the eighth planet from the Sun. The overlapping of Pluto and Neptune's orbits plays a crucial role in the occasional overtaking phenomenon. As you can see in the diagram, Pluto's elliptical orbit, shown in gray, crosses Neptune's circular path in blue. This crossing allows Pluto to come closer to the Sun for about 20 years during its 248-year orbit. Importantly, this overtaking relates to their distance from the Sun rather than physical movement past each other. Despite these overlaps, orbital resonance ensures that these two celestial bodies do not collide, maintaining a harmonious path through space. Now, let's explore the crucial concept of orbital resonance, which is key in preventing Neptune and Pluto from colliding. Despite their overlapping orbits, they are engaged in a 3-2 resonance. This means that for every 3 orbits Neptune completes around the Sun, Pluto completes 2. In the illustration, you can see the orbital paths highlighting this synchronization. This resonance ensures that when Pluto reaches its closest point to the Sun, where its path might potentially intersect with Neptune's, Neptune is always in a different part of its orbit. This cosmic dance maintains a safe distance between the two, averting any collision. In summary, Pluto's unique orbital path is highly eccentric, while Neptune's orbit remains near circular. This difference, along with the 3-2 orbital resonance, allows Pluto to periodically overtake Neptune in distance from the Sun. The visual here highlights the elliptical shape of Pluto's orbit compared to Neptune's circular path. It also emphasizes the fascinating dynamics of orbital resonance, which ensures that despite their overlapping paths, Pluto and Neptune maintain a safe distance. This fascinating celestial mechanics offers a glimpse into the complex dance of planetary orbits in our solar system.